I will run Spring Boot applications in Elastic Container Service. I hope it will be interesting and session will be mostly practical. I don't have many slides. I will make some hands-on, not maybe coding, but some hands-on activities. So I hope you will enjoy it. A few words about myself. My name is Alexander Marmin, and I'm Chief Software Engineer. Also, I write Java and talk about Java, conduct trainings about Java. So I'm doing a lot with Java. Also, I'm really keen on using AWS and have a couple of certificates. Let's take a look into the agenda of my talk today. First of all, it will be a very short introduction. We will talk about different compute options in AWS. And if you remember previously on January, we talked about running serverless applications, which are built on top of AWS Lambda. Today, we're going to talk about containers. So we will have a brief overview of useful cases when it's better to use containers instead of, for example, Lambdas or maybe anything else. And also the most important part of our talk today is a demo part. Let's start. As I said, we will start with compute options and what we have here. Speaking about AWS, we have actually one of the oldest services. It is called AWS Elastic Compute Cloud. That's why it is called EC2, because Compute Cloud. And it is possible to run almost everything, because what you get as a result, you get a virtual machine, which you can log into this virtual machine using simple SSH and install all the necessary software. To be honest, everything you need, you can install there and manage it on your own. Speaking about AWS EC2 instances, there are a few options regarding instance types. And of course, the main difference between them is cost. First of all, you can log in into AWS console and say, well, dear AWS, I'd like to have an EC2 instance in order to run something on it right now. And this kind of instance is called on-demand instance. And speaking about pricing for these instances, you're paying every hour. So you used instance, for example, 5 hours, you will pay for 5 hours. There is also another cost-saving option called reserved instances, and in this case, you're paying upfront. Let's say I am going to use instance of this type, of this size, to next 3 years, so that you will be charged. So you will pay for 3 years in advance. But because you're reserving some capacity in advance, you're buying instance in advance, you will pay less in comparison with on-demand instances. So this is the main cost-saving option, speaking about virtual machines. Also, this kind of instances are useful for cases when you have a steady workload. For example, you know that your application will be under the particular load during a significant period of time. That's why you can buy instance of a suitable time or book it for a significant amount of time. In case if you know that your application has scheduled workload, for example, at the beginning of every month, your users are logging in and perform some heavyweight operations like preparing some reporting or doing anything else, you know that during this period, you need to have additional capacity for your virtual machine, so that you can request scheduled instances. These instances, again, provide some cost saving, but not as significant as for reserved instances, but still, if you know that you need additional instances during some period of time, but after that instances are not required, you can buy scheduled instances. And also, of course, there are kind of instances called spot instances, in which you can request for kind of processing. For example, you have a pipeline and you need to you can interrupt your workload at almost any point, but you need a lot of machines for a very cheap price. That's why you can use on-spot instances. Also, there are two additional options, dedicated hosts and dedicated instances. In this case, you can say that, well, this virtual machine or even this, let's say, hard piece of hardware is dedicated to me only, and I will host all my software on a particular, let's say, hardware because I need to connect, for example, my hardware key with this instance. So that you can also ask Amazon to provide you with dedicated host or dedicated instance. Speaking about containers, there are two major container engines available in AWS. Of course, it is Elastic Kubernetes Service and Elastic Container Service. Speaking about Kubernetes and cloud, it is actually very the same Kubernetes you can run locally. You can, for example, you can install Kubernetes on your computer and run it. Speaking about Kubernetes in cloud, it is quite costly service because on the one hand, you're paying for instances where your worker nodes are run, and also you're paying for the control plane because you pay for it. And also we have Elastic Container Service. It is something in the, let's say, something in the middle between Docker and Kubernetes, because actually it is not a, let's say, not a real, let's say, Docker swarm. It is very similar, but again, it is not Kubernetes. And also what we have serverless compute options like AWS Lambda and AWS Fargate. And previously we have already talked a lot about Lambda, so my main topic for today is containers. And in common and in particular, we will talk about Elastic Container Service, not Kubernetes. Let's take a look and try to identify which workloads are suitable for containers, because again, you can order a virtual machine and run your workload there. And containers are good in the following use cases. For example, you're deploying in a hybrid environment, or you'd like to take your software and lift and shift it into the cloud. Let's say you're already running your containers, your application on-premise, and like to wrap this software in Docker images and take this software and just deploy it to the cloud. It is also a good way to start with containers. It is a good option for containers. Another useful point for containers is batch processing and after-scaling. Yes, of course, you can do after-scaling on top of EC2 instances. It's possible to group them into the after-scaling group, but speaking about containers, they provide less overhead here, especially in case if you run your containers on Fargate. And another important thing is that you can consume a little less resources in comparison with just because you can be more flexible under the load. Let's take a look into the launch types which is available for Elastic Container Services. And actually there are three launch types, and first of all, it is possible to run your containers inside your EC2 instances. And in this case, ECS will manage your containers, and you can use this launch type in case if your workload has a consistently high CPU usage or memory usage. It may be less expensive when running, for example, in Fargate. You can, let's say, buy a few EC2 instances upfront, for example, reserved instances, and run your ECS nodes on top of your EC2 instance. It will be, let's say, it will give you some cost saving. Or, for example, you have a very, let's say, you'd like to save some money, actually. This is the main point, but Also, in case if you're using EC2 launch type, you mostly will pay for EC2 instance, but not for time where your container is running. So, because in case if you buy for example, to big instance and running only a few containers in it, it is under, let's say, not good because your instance is not fully used. In case if you buy the small instance, again, you maybe need to buy one more instance. And what else? In case if you need to share some data between your containers, you can share it using different ways. Of course, you can connect your containers to, for example, let's say S3 storage, but in case if you'd like to connect your containers to EFS, it's better and much easier to use it, to implement it using EC2 launch type. Speaking about, or if you'd like to directly manage your infrastructure, for example, you have some keys which are connected to your hardware, for example, to your dedicated instance, it is also a good option. In case if you'd like to use Fargate launch type, it may be useful for cases when you like to have a very low overhead or you'd like to scale rapidly. In this case, new containers will be started significantly quicker. Or in case if you have a very small workloads which do not require significant amount of CPU or RAM, it's better to buy small containers, let's say small. It's possible to provide small amount of memory and small amount CPU to your containers and you will pay less. Or for example, you have a batch workload which need to be very quickly executed, but next amount of containers, amount of instances which are running currently need to be reduced back. If you'd like to know more about Fargate launch type, please follow this link. And also, there is the third type, it is external launch type. It is possible to register your own infrastructure or your virtual machine in ECS cluster. For example, you have a virtual machine in your on-premise data center and like to manage it from ECS console. It is also possible. And if you'd like to know more, follow this link. This is almost all regarding theory. Let's move forward and talk about application I'm going to run. I'm going to run a very simple examinator application. It is written in Java, but mostly I will show AWS today, but nevertheless, my application is written in Java. So what I have an examinator application. What this application is doing, it consists of three services: provider of question for math, for example, provider of question for history, and aggregator. Main idea of aggregator is that when it receives a request like please provide me 10 questions about math, 20 questions about history, just send requests to underlying services, and as soon as the responses are received, it combines them and returns back to the users. All the services are exposing REST endpoints and communicate in synchronous way. In order to run it, let's take a look into this application. Let's run it from IntelliJ. Right now, so what I have here, this is code I have. So what's here? If you take a look, you will see that it is a multi-module Maven project, which consists of many modules written in Java 11. It has a shared module called service common, and what else is here? Actually, nothing really special. Spring Boot starter web, configuration processor, Lombok Guava validator, and actuator. Speaking about aggregator service, it is a very simple service. It is a simple Java Spring Boot application, and this is the main entry point. What it takes a map of string and integer, and next forwards this map to exam provider. What exam provider is doing, it goes into the question provider, and question provider is actually providing the questions. What this question provider is doing? Actually, this question provider goes to aggregator config, take information about particular provider. Let's say if I'm asking questions about the month, it knows where to take questions regarding month. If I'm asking about questions about history, it knows where to take it from. What does it mean for us? It means that here in the application.yaml, I have information about all of them. And next, I have a application.yaml for a different profile. We will get back to it shortly. But that's actually all, to be honest. What's happening next? I'm taking URL from the configuration, sending a request, and next parsing the response. And response from different providers are aggregated together and returned back to the user. Let's make a very simple query to localhost 8080. Localhost 8080. Wow, get is not supported. Yes, because I need to send post. I'm sending a post with a simple body. Like I'm going math 10, history 10, content type application not supported. Let's add a header, accept application.json, sending unsupported media type. Come on, what's wrong? Content type, yes, content type. Content type, application.json. Works. Yeah, as you may see, it works. So questions are generated, application is working. And what I'm going to do today, I'd like to run this application in AWS. In order to do it, I need to have a few things. First of all, I need to have my source code somewhere in the storage. Speaking about AWS, it provides AWS code commits. I can use it as a storage for source code, but I like to use GitHub today, just because there is no significant difference and my code is already on GitHub. What I need to do next? I need to take my sources and build it using CodeBuild. Why? Because I'm going to run my application in ECS, and in order to do it, I need to have my Docker images built. That's why I do not want to build them locally. I will build them using CodeBuild. That's why I need to have a build spec.yaml file. We will take a look into it shortly. As soon as my code is built, containers are created, Docker images are created. I need to upload my Docker images to Elastic Container Registry. It is registry storage for images. And next, I will start running my containers. And in order to run them, I need VPC. I need Elastic Load Balancer, which will accept all requests. Next, I need ECS cluster. Inside this ECS cluster, I need to create, inside at least one availability zone, I need to create a public subnet and run everything there. This is my plan for today. Let's try to implement everything I planned. If you don't mind, I will log into my Amazon account, Amazon console. If you have any questions, do not hesitate to put them into the chat. I will take a look into the chat and try to answer all the questions. And what I need to start with. As I said, first of all, what I need to do is to build my code. And in order to build my code, what I need to have? I need to have container registry first, because as soon as code is built, it will upload my images to some registries. That's why first thing I'm going to create is Elastic Container Registry. Demo registry, and while it is while my stacks are being created, so we will take a look into the CloudFormation template for it. So if you take a look here, you will see that I have a few CloudFormation templates. Actually, I have 6 of them, and first template is needed in order to create repositories. I'm creating, because I have 3 services, Examinator, History, and Math providers, I need to create 3 repositories. This simple stack allows me to create all of them. If I take a look into the Elastic Container Registry service, you may see that I have 3 of them. They have quite strange URLs, but if you pay some attention, you will notice that this is my, let's say, account ID, region, and name of the registry I created. The next thing I need to create is configuration for build, actually. So I need to create a project in CodeBuild, demo build. While it is creating, I will go through my CloudFormation template and explain what you will see there, and we will take a look into it in console as well. So what is here? The main point here actually is the project. This is ECS example CodeBuild project. It is my artifact, my resource of type project, and it contains of a few things actually. The main thing here is that I'm saying that I'm going to take my sources from my GitHub repository, and I will build all my code which is in the main branch. What else is said here? It is also said that I'm not going to publish. I'm not going to publish any artifacts to the next steps. For example, if I have a pipeline which is created using code pipeline, I can say that, well, I have my sources, and from sources I will build artifacts, and these artifacts next will be used by code deploy to deploy. Right now I'm deploying separately. That's why I do not have a build code pipeline. That's why, as for me, there is no need to deal with all these artifacts. What else? Also, I'm saying that I'm running my code, my builds on a very small instance. It is Linux. I'm building inside the container, and I am going inside my container, communicate to Docker image. That's why I need to say that I will use a privileged mode. Why it is important? Because I'm running my code in Docker, I'm building my code on Docker container, and I need to publish build containers into Elastic Container Registry. That's why I'm saying that I'm running my build and privileged mode. What else is important for me? I need to have 2 environment variables inside my build script. We will take a look into it shortly. And variables are the following. I need to know a region, and I need to know my account ID. You may notice why I need it. It is because I will upload my images into Elastic Container Registry, and as I highlighted, in order to know where to publish them, I need to know my region and my account ID. And a few more things. I'd like to see some log information about my build, and also I need to allow my build to publish images. That's why I'm creating a service role. What this role is doing? This role, actually, role model in AWS is a way to provide permissions from something to something. And in this case, in my role, I'm saying that I'm allow CodeBuild, because I allow CodeBuild to assume this role to do 2 major things. First of all, I allow it to write logs, and also I allow my CodeBuild pipeline to do anything with my container registry. Actually, it is possible to make more granular actions and more granular permissions, but it is not so important for my current example. And also, I'd like not to store logs forever. I will, let's say, get rid of them every 3 days. While we were here, my build has been created, and let's open it. So this is how CodeBuild look in AWS console. So as you may see, I don't have anything else here. This is my build. Let me start it, and while it is building, we will go through some configuration options. So what's possible to configure? Of course, it's possible to configure some build pages. For example, you have seen maybe information about successful builds in a particular branch. On GitHub, it's possible to do the same using CodeBuild as well. I'm limiting number of concurrent builds, no more than one build. I do not allow public access and do not assign any tags. What else is important? Also, it's important to highlight where my CodeBuild is taking sources. Actually, as you may see, there are a few different providers. I can take my sources even from S3 bucket. I can take sources from Code Commit, Bitbucket, GitHub Enterprise, and so on. Because right now I'm using my public repository, there is no need to connect my CodeBuild with GitHub. But also I can say that I'm going to use my personal to access token, and as a result, it will be possible to choose here in the user interface from the list of my GitHub projects. Because my project actually, URL of my project is actually hard-coded here, not even hard-coded, but here in the location, there is no need to do it. If you use the additional configurations for clone depth and so on. Not so important, but what else? Environment. As you know, as I said, I'm using some environment variables, and also I'm running my code built inside Docker containers of Linux. Of course, I can run my builds inside Windows containers, and not only x86, but also ARM. It is also available. Here I can configure available resources for my containers, and as you may see in my CloudFormation template, there were some environment variables, but here they replaced with real values. And if necessary, I can connect my build pipeline with some file systems if necessary. For example, if I'd like to, I don't know, store something during the build. Build spec, we will get back to it shortly, but logs, of course, logs, it is just a configuration for logs. As soon as I'm starting my build, the build, as you may see, it creates a build run, and for every build run, what I have, of course, information about my build run, and also I have access to logs. You may ask, where is the configuration? How exactly my project should be built? And you will be right, because by default, my configuration for build is stored in the file called build spec. And of course, it's possible to write them right here, but it is not so useful. That's why, as well as it is possible to use, let's say, GitHub Actions file for configuration, it's possible to use Jenkins file for configuring Jenkins. What I'm going to use buildspec.yaml for running, for configuring my CodeBuild build. Yes. My build consists of a few phases, actually not so many, but they are the following: install, pre-build, build, and post-build. Let's take a look into them shortly. In the install phase, I can configure by environment. Let's say I'm going to I'm going to build my code using some runtime, for example, Java of a particular version, or maybe PHP, Ruby, Python, everything else. It means that you do not need to install everything you need for your build on your own. You can use pre-built runtimes. Of course, not all the runtimes are available. For example, there is no runtime for Java 17 yet, but I hope it will be available shortly. So that if you'd like to install something which is not available there, you can install it during pre-build phase. And here, for example, in the pre-build phase, I'm just checking that my Maven wrapper has an executable flag, or if not, I'm assigning it. What's happening here in the build? Actually, nothing interesting, but a few things. Let's take a look into it shortly in some details. So, Maven clean package. It is ordinary common to build Java application, but that's why I will not stress your attention on it. What I'm going to stress your attention to is this line. You know, right now, Docker introduced some limitations. So that's why if you're sending too many requests, you will be throttled. You may see the message like you need to log in before downloading some Docker image or base image. That's why, in order not to be throttled, I'm downloading base image for my Docker images, not from Docker Hub, but from Amazon Public Container Registry. If you take a look into the documentation, you will see that this is the official image for Amazon Careta 11 available from Amazon. But before using that, you need to log in. And this command allows me to log in, actually. So what I'm doing here, I'm getting a token or a password, let's say. I'm getting a password, get login password in the US West 2 region. And what I'm doing next, I'm logging into this repository where Amazon Careta is stored. And right after it, I'm building my own images. They will be built gracefully. And during the next step, post-build, I'm publishing my images to Elastic Container Registry. In order to publish, what I need to do, again, I need to log in into my account this time and just execute a Docker push. Let's take a look into the results of my build. At the very end of it, there should be information about successful build. Yeah, as you may see, build has happened successfully. My images also built successfully, and they were even successfully pushed to repository, to container registry. Let's take a look into the ECR to container registry and check that everything is here. Yes, everything is here. I have my images. Let's move forward, right? Let's move forward. What's next on my list? If we get back to the slides, the next step is to actually create all the infrastructure which will be needed to run my containers. So I'm going to CloudFormation again and creating one more stack. This time I will create VPC. VPC stands for Virtual Private Cloud. Let me put some default values here, and while it is creating, it will take some time. I will explain what is there. My VPC configuration is quite big, and it contains a CloudFormation template for VPC consists of a few sections. If we take a look into the previous, like this one, it consisted only of resources section, but right now it contains also parameters section. For example, I'd like to have some parameters and configure creation of my VPC in advance. But also I'm providing some default values like a name of my VPC, IP address blocks, and blocks for public and for private subnets. Let's take into the resources I'm creating. Of course, at the very beginning, I need to create VPC itself. So that's here I'm creating VPC and associating given CIDR block with init. I'm creating a few subnets, public subnet, two public subnets, and private subnet. You may ask why I'm creating two public subnets. It is because next I'm going to create a application load balancer, and in order to use it, I need to have at least two public subnets. What is the main difference between public subnets and private? Because public subnets are available for services from outside. And also I need to put my subnets in different availability zones. So that I'm associating them with VPC and saying that I'm using this intrinsic function to get availability zone. First availability zone in my region and second availability zone in my region. Also, I'm assigning them with some names and putting a flag that IP addresses should be associated on launch of instance. For example, if I launch an instance in this subnet, this instance will get IP address immediately, public IP address. If I am creating an instance in private subnet, this instance will get only a private IP address, but will not have a public IP address. In case if I'm using public subnet, it will have both. In order to access the internet, my services need to have internet gateway, and the internet gateway should be attached to my VPC. So this is what I'm doing. And next, I need to configure routing inside my VPC, inside my subnets. So I need to create a routing table inside VPC. I need to add a routing table. Route for my routing table. And what I'm saying here is that any requests should be sent actually to the internet gateway. And next, I'm associating this routing table with my subnets. I will not use private subnet, but if I want to provide this private subnet with access to the internet, what I need to do, I need to create a NAT gateway and associate NAT gateway with my subnet and configure routing table. In case if you take a look here, you will notice that my default route says that all the traffic is sent to internet gateway. In comparison, if I'm using my private subnet, I need to say that all the traffic should be sent to NAT gateway instead of internet gateway. What else I'm doing here? I'm creating load balancer. Load balancer will be an entry point of my application. It is internet-facing load balancer. It will have a security group. We will take a look into it shortly, and also it will be associated with public subnets, two public subnets. And type is application. Actually, there are three types of load balancers: application load balancer, classic load balancer, and network load balancer. And classic load balancer is almost deprecated, and it is not recommended to use it. A network load balancer is much more performant. In case if you need to use, for example, UDP in your application, it's better to use network load balancer. If you need to route mostly HTTP or WebSocket traffic, you're recommended to use application load balancer. I have a load balancer, and next I need to create a listener. A listener will accept all the requests and next forward it to target group. And this is my target group. And this is listener. It listens to port 80 and sends forward traffic to target group. My target group is quite interesting thing. It will forward traffic from port 80 to port 8080 because I'm running Java on port 8080. And also I need to send traffic only to healthy containers, only to healthy instances. That's why here in the target group, I'm configuring health checks. And for health checks, I will use actuator endpoint in my Java application. So if I'm adding in my Java configuration, my POM.xml file, this dependency, I will have a health endpoint, and this health endpoint will report on status of my application. Is it healthy or not right now? That's why I'm configuring it. Actually, there is no need to set the port for the second time. Traffic port, this one will be used by default. But for example, if your application is listening to 2 ports, it may be needed. And security groups. Security group is a way to restrict access from one resource to another. For example, here I'm allowing all my traffic. This is ingress security group. It is associated with my application load balancer, and this security group allows traffic on port 80 from anywhere, and no any other traffic is allowed. You may say that I'm not using HTTPS here, and that's true, I'm not using HTTPS here, but if I'd like to use it, I will need to add one more record from port and to port equal to 443. Right now, I'm using only port 80 on the HTTP traffic. But my containers need to talk to each other, and that's why I need to allow my containers to talk to each other on port 8080. Oh, sorry, it is another. I need to allow my containers to receive traffic from application load balancer. So as you may see here in the security group ingress, I'm saying that all traffic from everywhere is allowed. Here I'm saying that traffic on port 8080 is allowed from only for source security group, and this security group is security group from for my application load balancer. And first security group I need is my security group which allow communication between networks. My containers can be started in one or another public network, so that I need to allow containers talk to each other only and do not accept connections from anywhere else. So my containers in this case are available only from application load balancer. If we take a look into the CloudFormation, you may, ingress load balancer, what's in the, surprisingly, resource creation cancelled, what went wrong? Has VPC, has no internet gateway. Oh, fantastic, we will fix it on, we will have to fix it online, does not work. Actually, I did not expect that something will be broken right now. So that's, let me think, what is the easiest way to fix it? What it is saying? It is saying that load balancer was load balancer was created too early. So I need to assign internet gateway to my VPC first. This is what it is saying. So it says that first of all, you need to create internet gateway, and only after that you will be able to assign internet gateway load balancer. Okay, so while it is rolling back, it's it is done. Demo VPC. I will go through another stack. I will start creating Elastic Container Service Cluster, ECS cluster. Demo cluster. And so I will have two stacks in creation in progress. Let's take a look into the cluster. Actually, this is the cluster. Actually, this is all I need to declare in order to create Elastic Container Service Cluster. It will be created shortly. So cluster is ready. Let's go to cluster. Elastic Container Service. This is my cluster. As you may see, nothing is running. I do not have EC2 instances. I do not have external instances. I have no Fargate services up and running. Right? Right. While VPC is creating, I need to create one more resource using CloudFormation. I need to create configuration for my tasks. I need to create task definitions. I will go through task definitions shortly. I will start creation of them, and next explain what's happening. So public subnet, blah, blah, blah. It's happening. So in order to start my tasks in ECS, first of all, I need to create task definitions. What is task definition? More likely they will fail and will not create it, but still. So task definition is the definition of my services, or is like a description of what I need to, how exactly I need to create my containers. So this is the task definition. Task definition consists of a few parts, and the main part here is actually container definition. So my task can consist of many containers. For example, if I'd like to implement a sidecar car pattern. For example, I'd like to use Istio service mesh. I need to create container with my service, and I need to create a container with service mesh, with Istio. That's why I can declare multiple containers in my task. If you're familiar with Kubernetes, it is very similar to pod definition. My pod can Kubernetes pod also can consist of many containers, and so that here I'm declaring content of my container, name of container, image of my container, available CPU and memory for this particular container, and port mapping. So I'm receiving requests on port 8080, and this container is exposing port 8080. Also, I'm adding environment variables in order to start Spring with a different profile and configuring logs. This is configuration for logs, which says that, well, all the logs should be sent to this log group in CloudWatch. What else is available here? Also, I can configure amount of memory available for the whole task. In case if I have multiple containers, these resources will be distributed across them. Also, I need to configure runtime. It says that in order to run my task, I need to have CPU, ordinary CPU, and I'm going to run I'm going to run Linux inside. Why it is important? Because in opposite case, if you know, Windows virtualization runs a bit differently, and you can run Windows containers on Windows machine only. So that here, what I'm doing, I'm saying that I'm running my containers on top Linux container on Linux. And also, I'm saying that in order to run my tasks, I need to use Fargate only. So what does it mean? It means that here I can say that I may run my task on Fargate, on external run type, or EC2. But here I'm saying that Fargate only. So everything has been created. Let's take a look into the user interface. So these are my task definitions, 3 of them. Exam aggregator, every task definition is versioned, and it is already the 6th version of it. Let's take a look inside. What's here? Actually, there is the same AWS VPC network type, family compatibilities, compatible with both Fargate and EC2, but requires Fargate. Task size, some limitation. Task placement, not constraint. Placement is about placing of tasks, for example, inside EC2 instances. There are a few strategies which say that if you have, for example, many EC2 instances, you can say that one container per instance, or field first instance first of all, and next move to the second instance, and so on. So different strategies allow to packing your containers in different ways. These are containers which belong to my task, and environment variable, all other things. Volumes are not connected to it, and additional parameters. It is also necessary to have 2 roles, task role and task execution role. They are quite interesting. Task execution role required in order to upload, not upload, but download your Docker images from container registry, but task role is required when you're running your container. So there is a small difference between them. So task execution role is required to upload images from to download images from container registry and push logs, and task role required when your task is executed. For example, there is no actually need for Elastic Container Service as is to access S3, but in case if your service needs to access S3, you can provide it with access. So that's why there are 2 roles here. If you take a look into the JSON, you will see that actually this JSON is very similar to YAML I shown before. And tags, no tags right now. Speaking about CloudFormation. CloudFormation are very useful thing because it also not only creates my resources, but also provides me with some output. And here, as you may see, my VPC stack says that you have a application load balancer, and this is the URL you can use to access your application. I will copy to clipboard and show what is necessary to have this fancy output. In order to have this fancy output, I need to have an output section, and here inside this output section, I'm putting this information. For example, this is my ingress load balancer URL, name of my output, and this is the value of it. So as you may see, I'm using get@add intrinsic function and referencing to the load balancer's DNS name. And also, as you may see, I'm exporting some variables outside of my stack. Why it is needed? Because as you may see, I have many stacks here, and I need to send some information from one stack. I need to expose information from one stack and use it in another stack. That's why I'm using export here. Let's move forward, right? Do not hesitate to put your questions into the chat. As soon as I created my task definitions, what I need to do next, actually, the last one step is to create services from my task definitions. And again, I'm not going to do it on my own. I will rely on CloudFormation. It is actually possible to create of course, it is possible to create tasks manually, but in order to be time cautious, I'm creating them using CloudFormation. And while it is creating, let's take a look into the resources again, because here I have a few interesting things. Of course, first of all, what I have is service. And speaking about service, it is quite simple. It is service with name aggregator service. It should be started in a particular cluster. And here is an example of import value which was exported by another stack. So if I take a look into my ECS stack, you will see that actually there is an output value Amazon resource name of my Elastic Container Service cluster. And here, when I'm creating my task, I need to say in what exact cluster I'm going to run it. That's why here I'm referencing to a variable which was exported by another stack. I'm saying that I'd like to have one instance of my task, run it in Fargate, please. And this is network configuration. Network configuration is quite simple and straightforward. However, there are a few important things I'd like to stress your attention to. So I'm taking two subnets. I'm providing my service configuration with two subnets because actually it says that you have two subnets and please distribute evenly containers between these subnets. So ECS will distribute running containers between these subnets. Also, I'm providing security groups here. What security groups are available? Ingress security group, it is aggregator service, it is entry point, so that it should have it should be available from load balancer only, and it should talk to other services as well. So that there are two security groups. And also there is this thing. I'm right now, for simplicity, I'm assigning my containers with, I'm providing my containers with public IPs. It's not, maybe not a very good practice. It's possible to avoid it. And in order to avoid it, I will need to configure a few things. First of all, I will need to configure, let's start from the beginning. The main advantage of it is that my containers will have direct access to my ECR, container registry. In case if I'm not providing my containers with public IPs, I have two options. I need to add net gateway in order to let my services download images from container registry, and another option is to create a VPC endpoint. For simplicity, right now I'm assigning the public IPs, but it's possible not to assign containers, not to assign public IPs to containers. It is just for simplicity right now. And also I'm saying that this service should be created using this task definition. You remember on the previous step, we created task definitions with containers, resources, memory, and so on. And this is registration of my service in the application load balancer. This is an entry point service. That's why I'm saying that please register my service in the load balancer with a given in a given load balancer, and this is name of the container which will receive all the requests, and this is the port which is opened. Why it is important? Because, as I said, in my task I can have multiple containers in case if I decided to implement sidecar pattern. This is my entry point container. Let's check whether everything is correctly. Yeah, everything has been created, so all good. Also, I have a few more services, and these services are just providers. As you remember, they are not publicly accessible, but they should provide some, let's say, endpoints and some data for my aggregator. And here I have a bit different configuration. What I'm doing here, here I need to take a step back and say that I'm running my aggregator with a different Spring profile. If I take a look into my default profile, you may see that by default, endpoints for providers are the following. They are run on localhost. Of course, it is not an option when you have multiple services. They are somehow distributed across your network, across your VPC, so that you need to have a service registry, right? Right. In order to have a service registry, of course, you have multiple options. You can, for example, use Erica in case if you're using Spring, but also you can rely on Amazon infrastructure, so that I need to have these endpoints for my providers, like provider map.local as the name of my service and provider history.local as the name of my service. In order to have this naming strategy, in order to have it, I need to create a service registry. In order to create a service registry, what I'm doing, speaking about AWS, there are a few options how to implement a service registry. First of all, I can, and actually, to be honest, it is actually only one option, is to use Route 53. But for the Route 53, there are a few, let's say, interfaces. I can use Route 53 directly, or I can use Service Discovery, which uses Cloud Map under the hood, which uses Route 53, of course. And speaking about Route 53, I can create there a few namespaces. So then here I'm creating a Service Discovery private DNS namespace with name local and registering it in my VPC. So as a result of creating a resource of this type, I will have a top-level domain .local. And next, I need to register my, I need to create a registration for my service. It is like a name. Why I'm saying it, I can show. So if I go to Cloud Map, in namespaces, here I will see that there is one top-level domain namespace, and in actually this namespace is a Route 53 private hosted zone, and inside it I have a one service provider history. This is the service I registered. And the next step is to associate this, let's say, local domain name, private provider history.local, provider history.local, with some instance. And here, what I'm doing, I'm just relying on Elastic Container Service and saying that when you're ready, please register my service in this registration. So associate my container with this registration. This is what is happening here. If I go back to my cluster, here in my cluster, I will see that two services are up and running. I started two services in order not to spend additional money. It's enough to have two services right now. And for both of services, I see that every service has its own task. If I go deeper, I can see some logs here. Logs are also available. Task definition and task role. Also, I can see public IP address of my task. If I try to open this, try to access this IP, you may see it is not working just because my security group does not allow it to talk to each other. What's left? Actually, one single thing left. I need to demonstrate that everything is still working. How I will do it? I need to know IP address. You remember I copied it to, I need to know domain name of my application load balancer. Let's take a look into the load balancer. Yeah, sure. So speaking about VPC, there is actually nothing interesting in the VPC. You may see that it is just VPC. I have a few of them in my account, VPC, for example. And here I have a few subnets. For example, this is my public subnet. In my public subnet, I have route table. A route table says that all the traffic should be sent to internet gateway. And also here I have set of my internet gateway and security groups. I have a few security groups here, and as you may see, this security group, for example, allows access from another security group on port 8080. If I go to EC2 configuration, here I will see my load balancer. This is my load balancer. This is the DNS name for my load balancer. I copied it to clipboard once again. So my load balancer is associated with VPC, configured to use two availability zones, one security group, which allows access on port 80 only. And also there is an associated listener, which listens to port 80 only, not 443. So no HTTPS. And what it is doing, it is forwarding all the traffic to target group. Let's take a look into the target groups. Here I have target group, one target group with port which will forward all the traffic to port 80. And here I have one single target in my target group, which is healthy because actuator says that everything is healthy. And this is private IP address of my target. Let's finally try to send request. Tick. Oops. Why? Because I have only one provider, right? Sending request, history, likely history. Hooray, it is working. So what does it mean? It means that I managed to send my traffic through my computer, from my computer to application load balancer. Application load balancer forwarded my traffic to accepted my traffic by listener forwarded my traffic to target group forwarded my traffic to this target. This target is actually this task in the ECS and next aggregator, and next this task communicated to cloud map in order to have an IP address of the neighbor task. And as you may see, this is what is needed in order to run Java in cloud. Simple 6 steps and everything is working. Simple, really. That's all I have for today, to be honest. Let's go through slides once again. What's in the summary? There are a couple of services which allows you to run containers in the cloud. ECS, and we have already taken a look into it, and Kubernetes. ECS has 3 launch types, EC2, Fargate, and external. We have taken a look into the Fargate today. Also, there is a container registry to store Docker images, CodeBuild to build our code right in the cloud, and we have ECS to run containers. And we can use Cloud Map for service discovery, and there is no need to rely on anything like Evrika, for example. All the codes I shown today is available using this link, and also please follow the second link and provide me with a feedback on my talk. That's it.